we have started with the lesson, that is structure of an atom. I gave you introduction, and we also discussed about the fundamental particles of an atom. Now when we talk about the structure of an atom, now we know very well that is protons and neutrons are present in the center and the electrons revolve around the nucleus. That is proton and neutrons together is called nucleus, and the electrons will be revolving around the nucleus in their own orbit. That we know now. But earlier no one knew, that is the structure of atom, nobody knew, right? They never knew what are the particles. Slowly they discovered the particles, right? They discovered electron, then they discovered proton, later they discovered the neutron, right? So when these particles were discovered, as in when they started thinking how they are arranged, right? What might be the structure of an atom? Because we know first we were not knowing that what is matter made up of. Then we learned that matter is made up of tiny particle called atom. Now the question arises, what are the tiny particles? Whether atoms can be further divided, can it be further, is it indestructible, can we divide it further? Some told, like John Dalton said, that it cannot be divided, right? It is not divisible further. Later on, when scientists started carrying out their research work, their experiment proved that atoms can be further divisible. It can be further divided. That's how the scientists could find out these three fundamental particles. So when they discovered these particles, they started to think, okay, how they are arranged, what might be the structure of an atom. Now we know the structure of atom, but it was now after because we should be really thankful for their contribution. Otherwise, we wouldn't have known the structure of an atom. But there was a time when they were thinking, what might be the structure of an atom? Okay, so we will learn today the different structure proposed by the different scientists. Okay, so let us start with the first model proposed by J.J. Thomson. This is the earlier model of an atom. That's what we are going to learn. So this is the model, first one we are going, because J.J. Thomson was the first one to propose the model of atom. In the year 1904, he proposed the model of atom, okay, and he called this model as plum pudding model. He called this plum pudding model of an atom, or it is also referred as watermelon model. In your textbook is given Christmas pudding. That's also correct. There's nothing wrong in it. Okay. In your textbook they are given Christmas pudding model. Okay. Right. Plum pudding is nothing but a Christmas cake. Okay. So what was his structure? What was the structure proposed by J.J. Thomson? That's what we are going to learn. So J.J. Thomson, model of an atom. So according to him, the structure of an atom should be something which we can relate to a pudding, that is plum pudding. You know the pudding, plum pudding or the plum cake, right? The pudding part, he told, is a positive charge. The pudding part is positive charge. In that pudding you find the black currants. You know the black currants are nothing but the dried raisins, okay, dried grapes. Plum pudding you would have seen the black thing will be which will be present. Okay, so that time maybe they were not using the tutti frutti or cashew nut or almonds. Maybe they were using only the black that is a black currant. Okay, the black raisins. So the black raisins were the negatively charged particle, that is electron, because he was the one who discovered the electron. So according to him, the structure of an atom maybe it should be something like the Christmas pudding. The pudding part is a positive part and the black currant represents the electron, the negative part. That's what it does. Or we can compare this to a watermelon also. You know the watermelon, the red edible part. The red edible part of the watermelon represents the positive sphere. Okay, so according to him, an atom is a positive sphere in which the electrons are studded or embedded. Like we have the sky, right? In the night, in the sky, we can see the stars. So if you think the sky as an atom, and those stars are like electrons, it is scattered. That's the structure given by J.J. Thomson. So what did he propose? He said an atom consists of positively charged sphere. Positively charged sphere. That is the entire part. If this is the pudding, okay, the pudding or the watermelon. Okay, the edible part which we can eat, right? That is positive. Okay, an atom consists of positively charged sphere. Okay, I just draw like this. If this is positive sphere, if this is positive sphere, and the electrons are embedded in it. The electrons, like how the seeds present in the watermelon, the edible part, like that the electrons are present. The negatively charged particles are present. And I tell you, when he was not aware of protons nor neutrons, those were not discovered there. Okay, so this is the structure proposed by J.J. Thomson. That is, an atom consists of positively charged sphere and the electrons are embedded in it. Then he says the negative and positive charges are equal in magnitude. That means when you talk about the positive charge particles, so the number of positive charge is equal to number of negative charge. Okay, say now you have two positive charges are there, two negative charges are present. That's what he says. The negative and positive charge are equal in magnitude, and because of which an atom is electrically neutral. You know very well, when +2 and -2 is there, what happens? It gets cancelled. Right? Or +1 and -1 is there, what? It will get cancelled. You learned it in maths. Okay, so as they are equal in magnitude, so the atom as a whole is electrically neutral. So this is the model proposed by J.J. Thomson. What is it called? It is called plum pudding model or watermelon model, or in a textbook is given Christmas pudding. Okay. Now, what is the structure according to him? An atom is made up of positive sphere. In that positive sphere, you find the electrons which are studded or embedded on it. So next time when you eat a watermelon or a plum cake, you should know whatever the pudding part you are eating, according to J.J. Thomson, it is the positive part, and the black currant or that raisins, or kishmish, what we say, right? That represents the electron. That was according to J.J. Thomson. Because later on it is changed, we know very well, because as the scientists further investigated, they carried out experiment, so they found something was not correct, something is missing. Though this part, the second point was right. Even now we know very well, atoms are electrically neutral. That's why whenever we represent the name of an atom, whether it is chlorine, Cl, argon, Ar, right? So we don't represent any charge because we are representing the atom. Atom is always neutral. It is electrically neutral. The reason because the number of positive charge is equal to number of negative charge, because we know very well, we have learnt it, right? Number of protons are always equal to number of electrons. That you have to keep it in mind. Because of which atoms are electrically neutral. Okay, so this I hope you understood. So this is the J.J. Thomson's model of atom. As just now I told you, when other scientists started working or carrying out their experiment based on J.J. Thomson's proposed, like whatever the model he proposed, based on that, when they started working on it, so there were some it didn't explain certain things. So again, this model was not there. I mean, that is, this model is no more. Nobody follows this model. We know very well what is the model of what is the structure of an atom. We know now, right? So this is discarded. This model is discarded, but we give him the due respect because we know very well the second point is actually correct. And one more thing is, he was the one at least tried. Okay, later on others followed. So next model is Rutherford's model of an atom. Rutherford scattering experiment. Let us learn.